it's recording while
Yeah, now
you're...
it's recording. Yeah, so it's recording right now, and then it just...
And then I pause it.
I'll pause.
Alright, you guys are going to learn about 4.3 right now. Sorry I couldn't be with you today, but I think you guys will like this. So, 4.3 deals with the standard complex form, A plus BI. And we have the real piece, and then we have the imaginary piece. So the first thing we're going to do is we're going to graph that in a complex plane. So a complex plane looks a lot like an XY axis, except this is considered the real axis, and this is considered the imaginary. So if I were to graph anything really, but we can just pick 3 plus 2i. If I were to graph that, I would go 3 on my real, and I would go up 2 on my imaginary, and I have this piece right here. That's 3 plus 2i. Yeah, so it's pretty easy. If I wanted, we could pick a different one. If I wanted to graph negative 4 plus 4i, negative 4 is my real piece, so I would go 4 on that axis, and then I'd have to go up 4 because my imaginary is plus 4, 1, 2, 3, 4. So now I have this, and this is my point right here, 4 plus 4i. So the goal of today, and it's pretty simple, is just to take something from standard complex form A plus BI and move it into trig form. And it's actually pretty easy. There's only two pieces that you need. You need to have the hypotenuse of the triangle, and you have to find the angle. So it's a lot like a vector. So in order to do that, we look at our components. I have 4 plus 4i. So I know that this is, oh actually that's minus 4, isn't it? So I know that that's minus 4, and I know that that's up 4. So if I want to find my r value for that, I just use Pythagoras, the square root of 4 squared plus negative 4 squared. So r is just going to be the square root of 32. So if I were to write this in trig form, I would start off with r cosine of theta plus I sine of theta. So I already know the r value. I already know the r value is the square root of 32. Okay? Now the only question is, what is my angle? What is my theta? And actually this is just like when we did vectors also. In order to find that theta, I'm going to use the tangent. So tangent of theta equals opposite. So if I go opposite over adjacent, so opposite is 4 and adjacent is minus 4. And if you take the inverse tangent of that, I believe you get negative 45 degrees. Now this is the part that we'll fight about. Negative 45 degrees, I have to report an angle in the second quadrant. And if I know that theta is 45 degrees, and I'm going to go ahead and label that right here. If I know that theta is 45, then what is that angle right there? Well, it's got to be 180 minus 45. Or, what is 180 minus 45? 135. So the square root of 32 cosine of 135 plus I sine of 135. I ran out of room right there. Let me see if I can write that a little bit better. So I'm even going to change the color so you guys get this. Alright, I know the r is the square root of 32 because that's the hypotenuse. Okay? And then using the components 4 and negative 4, I was able to find the angle, which was 135 degrees. So now, I've written it in standard complex form, and I've written it in trig form. And that is our goal for today. If you can do that, then you can answer all these questions right here. It's really simple. What picture did I draw? Well, I drew a triangle. Alright, now that you guys saw how that worked, let's go ahead and take some notes. So according to your sheet, a complex plane, on a complex plane I have the real and then the imaginary axis. So we can write a complex number a plus bi. We can go ahead and graph that. So we can go over a and we can go up b. So we get that point right there, that is a plus bi. And now we have to go ahead and find the r value. The r value is actually called the modulus, but in order to find the r value, it means the absolute value of a plus bi, and I'm going to draw it on here. In order to find that r value, I just merely use Pythagoras. So I do the square root of a squared plus b squared. So I'm just using my real component and my imaginary component to find that r, or that hypotenuse. The next question is, how do I find an angle theta? So my theta is right there. In order to do that, again, I take both my components. I have my a and my b. So to find that angle, tangent of theta equals opposite, which is going to be b over a, and then in order to find that angle theta, I use the inverse tangent of b over a. Okay? So once I have that r and theta, I can write my complex number in trig form, r times the cosine of theta plus I sine of theta. Okay? So pretty easy. Once I have the picture drawn, I can find r by using Pythagoras. Not too bad at all. Then I can find my angle by using the tangent. So the same stuff that we've already done, and now we're just going to put it into practice. So your notes at the top should be pretty complete. So let's go ahead and do a couple practice problems and we'll see where you guys are at. So the directions say to represent the complex number graphically and then find the trig form of the number. So if I were to represent this graphically, my real value is -2, and again my real axis is right there. My imaginary value is also -2, so I have that point right there, -2, 2. And then it says to find the trig form of the number, so I'm going to have to find two things. I'm going to have to find that r value, but that's pretty easy because I have 2 and I have 2. So in order to find my r, I just use Pythagoras, 2 squared plus -2 squared. I guess they're both technically negative. So that gives me the square root of 8 for my r. And then to find my theta that's right there, I'm going to go ahead and use the tangent. So if I use the inverse tangent of -2 over -2, I think I get theta is 45 degrees. I cannot report something in the third quadrant with 45 degrees, so I do 45 plus 180 is 225. So now I'm ready to write it in trig form. I have the square root of 8 cosine of 225 plus I sine 225. So I have my answer. Easy. So now I'm going to make you work a little bit harder for number 2. Right away people get freaked out because there's a square root of 2 in there, but it's really not that big a deal. So first thing I'm going to do is graph it. 2 times the square root of 2 is my real. It doesn't matter exactly where that is. I just know I go over 2 times the square root of 2. Then I need to go down I. Again, that's just going to be -1. So I go down -1. And now I can find my trig form. I need to find r, and I need to find my angle theta. So in order to find r, I use Pythagoras. It's always interesting to see how people put 2 squared root of 2 squared plus -1 squared. So 2 squared root of 2 squared is going to be 2 squared, which is 4, and then the square root of 2 squared, which is 2. So 2 squared root of 2 is 8 plus 1. That's the square root of 9, which is equal to 3. Alright, and then in order to find theta, I can say tangent of theta equals -1 divided by 2 square root of 2. Again, you better put all of that in parentheses when you put it in your calculator, but I believe your calculator gives you -19.5 degrees. Alright, so when I report this answer, I'm going to say 3 parentheses cosine. I can't use 19.5 because that's -19.5 because I want to be between 0 and 360. So 360 minus 19.5 is 340.5. So I got 340.5 plus I sine of 340.5. I'll fit that in as well as I can. Oh man, that's worse. This is 340.5 and that is 340.5. They're always the same. So again, once I have it graphed, I have a right triangle, and then once I have a right triangle, we all know how to use Pythagoras, and we all know how to use the inverse tangent to put it into trig form. Alright, now we get to do the easy problem. So it says represent the complex number graphically and then find the standard form of the number. So remember, we want our answer to be an a plus bi. So I'm actually going to do the a plus bi first because it's easiest. All I do is distribute to both pieces. So I do 5 times the cosine of 135, and then I do 5 times the sine of 135. So if I were to do this, I know, well actually let's go ahead and graph it. Maybe this will be just as easy. 135 is going to be in my second quadrant, and I know that the modulus is 5, or that hypotenuse is 5, and I know 135 is the same as 45 degrees right there. So now the question is, what's my A component and what's my B component? So if you take your calculator right now and do 5 times the cosine of 135, I believe you get 5 square root of 2 over 2. Alright, let me take that back. I was using some exact coordinates there with my unit circle, but I won't do that to you guys right now. I'll just do 5 cosine of 135 in my calculator, and I get -3.5. Plus, when I do 5 times the sine of 135, I get -3.5i. So I started off in trig form, and when I distributed that 5, I ended up with standard complex form. So very easy to go from this to the other, and easy to graph. I know that 135 is right there. I know that is my 135 degrees, which puts me in the second quadrant. So for the second one, I'll go back to our lovely unit circle in order to do it. I know that the cosine of pi over 3 is in my first quadrant. It is right there, and the coordinates are 1/2 and square root of 3 over 2. So the cosine of pi over 3, I can rewrite this as 8. Cosine of pi over 3 is my x-coordinate, so that's 1/2 plus I sine of pi over 3, which is square root of 3 over 2. So now when I distribute my 8 to both pieces, I get 4 plus 4 times the square root of 3i. And I'm done. I have my answer. Now, if you want to go ahead and punch that into your calculator, you can easily say 8 cosine of 60 degrees plus I sine of 60 degrees. And when you distribute, I bet you get the exact same answer as I do. You just have to be careful because 4 times the square root of 3 is 6.92, but you recognize we wrote it a little bit more accurately using 4 square root of 3. Alright, and now we're down to the end. So the last thing you have to do is you have to be able to, in number 5, we are going to multiply numbers in trig form, complex numbers in trig form, and then in number 6 we're going to divide complex numbers in trig form. And it looks really complicated when you first look at it, but actually this is the easiest part of the whole unit. So I'm going to get out of your way a little bit. on page 338 to 339 in your book. There are two excellent examples right in front of you that go through exactly what you have to do in order to multiply and divide complex numbers. So I'm going to allow you to look at that. The formula's right there. I want to see if you can interpret it, and then this is something that I will check on your notes when I come to class on Friday. Let's see what you got done. All right. Good luck. Your assignment's at the bottom of the paper. Remember, it's all the odd problems, so get rolling on them tonight. And then tomorrow when we get to class, I can answer a bunch of your questions. All right? Thanks, guys. We'll see you tomorrow.